and welcome to this exclusive speaker interview for Datacloud USA, taking place 17th to 18th of September in Austin this year. I'm Lottie, and I'm leading on the content for Datacloud USA this year, and I'm delighted to be joined by Bill Kleyman, CEO and co-founder of Apollo.us. Today we'll be discussing the topic on the front of everyone's minds, artificial intelligence. But before we start, Bill, would you tell us a little bit about yourself and your career in the data center space?
Yes, thank you so much for having me, Lottie. And hey, everybody watching, it's a pleasure to connect with you folks. And so, hi, drop a comment or a like, and hopefully get a chance to see you out in Austin. You could just look for the energetic chipmunk with the cowboy hat on. Like Lottie said, I'm Bill Kleyman. I'm the CEO of Apollo.us, and we are a GPU ecosystem AI tool platform. Basically, an AI MLOps platform that's built for the data center to allow folks to consume AI and ML resources that are all at the top of our minds today. I've been in the industry for a while. I'm really lucky. I got a network engineering degree in 2005 and then started working in the data center space in 2006. But even back then, we called them like data closets and network rooms. We were like nothing fancy as we've got right now. Over the years, I got another master's in information security, spent a lot of time in this industry, whether it's, working with virtualization, cloud. My last foray was at a wonderful company that I learned a lot from, was at Switch Data Centers. I was their executive vice president. And was a part of the executive team that saw them go private for $11 billion. I left, and now I get a chance to do some really cool stuff with physical infrastructure, massively dense systems, really expensive NVIDIA, AMD, and Intel gear to process AI and ML, and I get to control the keys to all of that kingdom through the software layer that I have.
Oh, wow, amazing. Thank you, Bill. So let's start off from the beginning of the AI journey. What are the key considerations when designing for AI deployment?
It's a great question, right? And I know we only have a few minutes here, but it's not like any of this stuff is new. AI has been around for a very, very, very long time. But what has ultimately changed? Okay, everybody. In the past, we could validate a market, right? And then we could say, okay, cool. Lottie has got this amazing email server feature. She's going to go out and validate this market. And she did. She's got 100,000 people. Then all of a sudden, she's going to go to Bill Kleyman data centers and say, hey, Bill, I've got 100,000 people that want to use my really cool email feature. Can you position me? Can you put some really cool stuff in your facility? Hey, no problem. It's an email server. Put a bunch of pizza boxes in, a couple of pieces of storage. You're good to go. Oh, my goodness. Everything has fundamentally changed. Same scenario. Lottie goes out there. She's got this really cool generative AI use case, right? But it requires a lot of training. She validates 100,000 customers. She goes to Bill Kleyman data center and says, Bill, I got to put these 4,000 H100s to support my new use cases. You know what I'm going to say? No, not because I don't want to, but because I can't, because of greater level of densities, because of power consumption, because we're taking an ecosystem from 10, 15 kW per rack to 60 to 70 kW per rack. So there's a big question. How do you create something that's prepared, something that's actually ready to support AI? We've been, we've been working with a couple of different data center partners who have gone on this journey with us, transitioning away from an organization that can support 10, 15 kW to deploying things like direct-to-chip liquid cooling, rear door heat exchangers, rating their systems to like 70 kW per rack so they can put more of those DGX systems in there. Let me answer this question that you made with one very simple example, right? If our industry currently averages 10 to 15 kW, kilowatts per rack, how much stuff and equipment you can actually put into a rack, and one NVIDIA DGX node takes up about 8U in a rack, is 10.2 kilowatts. So if your entire rack can only do 10 to 15 and one unit is 10.2, how many of these are going to be put in a rack? Not very many. It's going to be one and a whole bunch of blinking panels. So when we come to the age of AI, GPUs in the data center, I am of the opinion that you need two things to be successful: power and bravery. You got to be brave in this market. There are going to be some capital expenditures. And to that extent, it's understanding improved containment, understanding that, and please, everybody listen, we're done. Physics has forced us to reach the limitation of how much air can dissipate heat. from mechanical equipment. So now we have to look at things like rear door heat exchangers, direct-to-chip liquid cooling, better methods to deploy and support this emerging market. And believe me, there is a very hungry customer enterprise base that understands the economics of going to the cloud, that doesn't want the information to be used to train some big foundational model. So that's why what we're seeing is organizations, enterprises going to their data center partners and saying, you have my most critical ecosystems already. Can you take my AI workloads? And many aren't ready. So Lottie, to answer your question, it is a rethink in engineering for, even if you're using a raised floor, are your tiles rated to handle the weight of the new AI gear that's coming in? Are you capable of cooling them? Do you have backup systems? Do you have the level of density? Can you bring water into your facility potentially, or some kind of a dielectric mineral oil, for example? How do you support this greater level of density and multiple? Also, where do you find the power to support all of this? Just to get started, you have to be brave in asking those questions of how do I rethink my architecture to support all of these new kinds of use cases? And my gosh, I don't know what to say. The amount of uptick that we're seeing in this industry is extraordinary. I'll give you one example. The president of the Utilities Commissions in Arizona recently came out and said that there's 11 gigawatts of demand for 2025. It took the state of Arizona 138 years to get to 11 gigawatts. And it's got this demand all into next year. Now, not everyone's going to get it. They're going to be in line. They don't have 11 gigawatts to distribute. But holy cow, data center demand is driving this kind of allocation. And believe me, AI is the use case.
Yeah, absolutely. And I mean, that point on power really does bring us on to my next question, which is how can we overcome these power constraints to allow for these new workloads, and what role will technologies like SMRs play?
Oh, I love that question. I absolutely love that question because, we're reaching a point where, I was at an event recently and JLL stood up and just like, in a quiet manner, put up the fact that we're seeing deal sizes, single transaction sizes, upwards of 300 to 400 megawatts per opportunity. Now, I need you to understand the scale of this. India, right, currently the most populous country in the world, consumes about 400 to 500 megawatts in data center capacity. South America, 300 to 400 megawatts. So in the United States, we have single transaction sizes of 300 megawatts. Is extraordinary. Now, that pressure is multiplied 10 times places like Europe, where because of GDPR and the all-new AI Act, congratulations Europe, which was passed recently, there's even more scrutiny around what data can live in big hyperscalers and cloud environments and what needs to be held on-prem. But in Europe, you're seeing even more of those power constraints. Okay, let's answer this question. When we take a look at the power environment, we know like places of Northern Virginia, 0% capacity. Like there's just not enough power for us to deliver. But secondary and tertiary markets like Omaha, Nebraska, Lafayette, Indiana, Wyoming, North and South Dakota, who have more amicable business climates and areas available where they can deliver some of this power, are going to start emerging as major hubs. Now, back to your point, SMR, small modular reactors, I absolutely believe that we're going to see more investments into that. For example, I think you saw Equinix put in $25 million of prepayment for their Oklo facility. Standard Power out in Pennsylvania and Ohio is going to be using completely nuclear power through their purchasing power agreement. In fact, there's a really cool thing. Standard Power actually knocked down a coal-powered the coal-powered plant, and the big chimney thing came down, and they were all proud of it because now they're going to go nuclear. At Data Center World, AFCOM Data Center World this year in April in Washington, D.C., Last Energy parked a 20 megawatt small modular reactor in front of the convention hall. I'm not kidding. They put it on the back of a flatbed semi, parked it, raised it up, and stood it up. Everything. The centrifuge was there, the pressurization, the water valves, everything was there, except, of course, the fuel, right? The U.S. government made sure we were very clear on that. They're like, hey, Bill, the White House is 5 blocks that way. No fuel, no uranium. We're like, of course, you just want to have the unit up. And so we did. It uses 20% enriched uranium. Obviously, none of that anywhere near. But the fact is that we stood up an SMR prototype, a 20 megawatt SMR at this convention hall, and people really had a chance to see it, touch it, feel it, understand what these technologies look like. Because the reality of the situation is that the wind isn't always going to blow and then the sun isn't always going to shine. So we have to get a base load capacity for these kinds of power systems. Personally speaking, I think bringing new fossil fuel coal powered plants is absolutely backwards, that we have to manage the most advanced technologies impacting humanity with fossil fuel, right? So this new alternate to clean energy is there. At Data Center World, we had Dr. Riyam Bahran from the White House Technology Office, literally the West Wing. It wasn't a very long drive. It was about 5 blocks. Came to us and delivered the keynote address on a Wednesday, and he made some very, very important points. Everybody listening, there is going to be more grants and more support from the US government to support small modular reactor and nuclear technologies. And from a US government perspective, any administration, let me just be clear about that, they see that our ability to create distributed, connected, great base power systems is not just great for clean energy, but also for national security. So there is a massive investment happening, not just from our industry in the data center space, but also from governments, from grants, from different institutions like Idaho National Lab in terms of what they're developing for smaller, more containerized technologies. In the past, we used to say this technology is like 15, 20 years out. I don't believe that. 5 to 10 years, there's going to be an expediting factor to getting more nuclear regulatory commission licensing and certifications. I absolutely feel that we're going to have these kinds of systems up and running very fast. So like the last energy example, literally you can put one of those things on the back of a semi truck and deliver them. They want to build warehouses full of them. So Lottie data centers in the middle of Nebraska or Oklahoma says, I have plenty of fiber, got plenty of land, got plenty of water. I don't have enough power, so I need 80 megawatts. Put 4 of those things on the back of a truck, deliver them to my facility. I can connect them behind the grid, and I'm up and running. Now, that's the dream, right? There's challenges, obviously. Regulations, local communities are going to say, cool, where's the uranium going to be coming from? Where are you going to store it? How are you going to protect it? What happens to my community? What happens to the waste? So there's still questions around some of that, although many of those have been answered in terms of how effectively these kinds of technologies can be delivered. Hydrogen is around the corner. Right now, it's just a little nascent to the extent of both the production of the hydrogen all the way to the delivery of the hydrogen to the end point. Unfortunately, is still kind of cost prohibitive and resource intensive to the extent where you start to negate some of those efficiency and sustainability benefits that you get by producing and then delivering this hydrogen. That's not going to be the case for long. I do believe that hydrogen is going to be a big impactor. Similarly, not just SMRs, microgrids do a really great job of aggregating different power sources and feeds, everything from natural gas, renewable natural gas, and so on. So, there's a lot of really cool things we can take a look at, but I'm excited for a nuclear future. In fact, everybody listening, I just wrote an article on data center knowledge welcoming you all to the nuclear era of the data center. And if you're curious, you can see what that last energy SMR looked like, because I absolutely took a picture of it parked in front of the convention hall.
Well, thank you, Bill. That's really interesting. And there's definitely some great advancements in the SMR space. So obviously, we both know that AI will continually evolve and advance over the next few years. So I'd be interested to hear your perspective on how the industry needs to adapt to prepare for the AI of the future.
There's so many future thinking things I can say here and try and impress upon everybody listening, but I kind of want to take it to a human level for just a second, okay, everybody? This isn't a shift in technology. This is a shift in humanity. And please follow me for a second. Get off your Amazon shopping list for a second. Just listen for this little bit of statement here. Alta Vista came out in 1995, Ask Jeeves in 96, and September of 1998 is when Google came out. And you and I and every single generation all over the world up until this point has been conditioned to interact with data in a very particular way, a blue link. That's it. SharePoint, internal documents, Google search engines, put in your query, you get a blue link. That's not the case anymore. Almost overnight, it feels like every single person listening, if you used Google or Bing, it's not a blue link anymore, is it? Right? It's a generative AI response. And that shift has been so rapid and drastic. Over the 30 years of doing something in a specific way has literally been turned on its head, because now we can get wholly unique conscious answers back by asking data a question, which is extraordinary. This is not a fad. Do you guys want to know what a fad is? I'll show you what a fad is. This is a fad. Fidget spinners! Fidget spinners were a fad. This is as much of a fad as it was when we stopped riding horses, started driving cars, when we stopped taking trains and started flying airplanes. This is a shift in humanity's way of how we interact with data. To your question, Lottie, we have to be prepared to support some of the most advanced use cases in the world. Between now and the next 3 years, 95 to 98% of all applications are going to have neural network, large language models, or some kind of a generative technology built into it. What we're seeing now is the democratization of AI, a technology that becomes available to anybody to use, to dream of use cases to support this. But you also have a market that's much more knowledgeable and much more keen on the economics of deploying this kind of infrastructure, which means they want to work with their data center partner. So to support the AI of the future, remarkably, as a facility, you need to focus less on the software and more on the infrastructure that can support it. Many times we consider when the turn of the century, turn of the century, 1990 to 2000, when the internet started to come out, the hyperscalers were the ones that won, right? They got a chance to write the rules for the internet, and then we were relegated to Exchange servers, SQL farms, VMware, and Citrix. And now it feels like the same thing is happening, but the difference is the enterprise doesn't necessarily want to go to the cloud by default. They want to use your infrastructure to support their most advanced AI workloads. So this is your moment. Be brave. Understand what your clients want, what they're asking for, and how you can build a facility that can support future ecosystems. Understanding that lead times for much of this is really, really difficult. Like a Caterpillar, 2.5 megawatt generator is like 52 plus weeks to get that. So you have to start thinking of how do I support these environments today, because these aren't pizza box servers. These aren't SQL, servers or Exchange or whatever you want to call it. This is a fundamentally different type of architecture that needs a new approach to it. That's how you support them. Have open, good conversations with your customers and understand that the way you've done computing traditionally, it's going to have to change. You're going to have to be brave through that change.
Oh, well, Bill, it's been an absolute pleasure speaking with you as per usual, and I can't wait to continue the conversation at Datacloud USA this September. Thank you everyone for watching, and please do reach out if you're interested in participating, and I will follow up with more details. Thank you, Bill.
Thank you. See you soon.